So our homework solutions for day 2.10, this involves word problems. And word problems are where we use real-world scenarios to illustrate what we've learned already. We're actually putting into practice all the numbers and formulas that we've used. So our first scenario or real-world example. The ABC Repair Company charges customers $40 just for examining and estimating the cost of repairing a broken appliance, and $30 an hour for labor to repair it. So, even before they start doing any work on it, before they started putting any hours into repairing it, they charge an upfront cost of $40. And this is pretty standard with many repair shops, including auto repair shops. They charge a shop fee of just bringing whatever item needs to be repaired. When you bring it in the front door, right away you're given an upfront charge, and in this case it is $40. Now we have a table of values where N is the number of hours spent repairing an appliance, and C is the total cost after so many hours. So here we have this N for 0 hours and a cost of $40. And once again, this is just because even before the repairs start, you're charged that upfront cost of $40. After 2 hours, the cost is $100. After 4, $160, and so on. So we have these points which we can plot on our graph. So there they are. We see that our initial value is 40. Our y-intercept is 40. And every hour, the charge goes up by $30. So since the y-intercept is 40 and the rate of change is 30 per hour, we can write an equation that says C equals 30 times N, the number of hours, plus 40. What is the slope in this relationship, and what does it represent in this problem? Well, we can just look at our equation right here and see that our slope is 30. What does it represent? It represents the amount that is charged for each hour of repair time. So M equals 30, and it represents the cost per hour. What is the y-intercept in this relationship? And what does it represent in this problem? Well, looking at our equation, we can see that the y-intercept is 40. So we can say B equals 40. And it represents the upfront cost, or the initial cost, before any work is done at all. Then question E asks, by looking on the graph, how much would it cost for repairs if the work took 5 hours? And there's a couple of ways to figure this out, but they do tell us by looking on the graph. So let's do that. Here we just travel along until we get to the 5-hour point. And then from there we go directly vertically until we reach our graph. And we can see that it takes us to the about $190 here. So 5 hours takes us up to the graph at the $190 mark. So we did that graphically just by looking at the graph, but we could have also done it a different way. We could have plugged in the 5 hours into our formula and got a cost of $190. Question F also says by looking on the graph, how many hours of labor were required to repair an appliance if it costs $340? Well, now we do it a different way. We go up to the 340 mark on our cost. We travel directly horizontally across the graph and then directly down, and we see that if something's going to cost $340, it would have required 10 hours of repair time. However, we could have done this slightly differently. We could have just set up our formula and plugged in 340, which is our cost, and solved for n. And doing it this way, algebraically, we come up with a value of 10. So 10 hours for a repair job that costs $340. Question number 2. A biologist studied a certain kind of tree for the past 10 years. She found that the diameter of the tree increased 2 centimeters each year. When the biologist began measuring the diameter, the diameter was 80 centimeters. Okay, so in questions like these, we usually have something that's changing. Sometimes it's changing over time, sometimes it's changing over distance. And in these kind of questions, the time or the distance is usually along the x-axis. The amount that it's changing, or the amount the cost is increasing, is usually along the y-axis. How much it's changing per x unit tells us what the slope is. So, in questions like this, if you look for words like each or per, this will tell you usually what the slope is. It's increasing 2 centimeters each year, or maybe 2 centimeters per year. So this will often give you a little clue in these word problems as to what the slope or the rate of change is. It changes 2 centimeters every year. These are our years here represented by t. It starts with an initial value, and that initial value is the slope, the y-intercept, or the value of b. So here we're measuring diameter. It's increasing 2 centimeters every year, but it starts with an initial value of 80. This b, or y-intercept, is usually the initial value. In our previous appliance question, it was the initial cost. In this question, it's the initial or starting diameter at year 0. So there's our equation. Diameter equals 2 times the number of years plus 80. Question C, what is the slope of the relationship and what does it represent in this problem? Well, once we have the equation, we can see that the slope is 2, and it represents the number of centimeters that are grown each year. D, what is the y-intercept in this relationship and what does it represent in this problem? Well, the y-intercept is 80 right here. And again, as we said before, it represents the initial value or the initial diameter when the biologist started taking measurements at year 0. Now we're asked, what was the diameter of the tree after 7 years? So what we can do is we can just move along our x-axis until we get to 7 years. And then directly vertical from there, we move up until we hit the graph. And then we just read what the measurement is at that point. So at 7 years, the diameter was 94, because that's what the y value is, or that's what the diameter value is at 7 years. Question F. After how many years was the diameter 92? Well, we just work backwards this time. This time we go up to 92, and we move across horizontally until we reach the graph, and then we read down, and we see how many years had elapsed after at this point, and we can see that the diameter was 92 at the 6-year mark down here. The XYZ taxi company charges customers $5 at the start of a fare, and then $2 per kilometer the taxi drives its customers. So here's this word per again. It's the value that it's how much is changing per kilometer. And when you see this word here, you can be pretty sure that that will be the slope. Okay? So here along the x-axis, we have the kilometers, and here along the y-axis, we have the cost. So we can see right here that the initial cost is $5. And when you see something like this, like a starting cost or a starting diameter, the starting cost at where x is 0, that's going to be our b value, or y-intercept. So if we know that our m value is 2 and our b value is 5, we have enough information to write our equation. Let's take that back. Y equals mx plus b. The cost will be 2 times the number of kilometers plus an initial cost of 5. And this is what it looks like on the graph.